Thank you. Welcome to this last presentation for this conference. I know some of you met me yesterday and they were leaving this morning. They could not come. So this session is recorded, so hopefully the people who missed the session will be able to watch it. So I have been talking about Columnstore index for many years, and one question I have is, how many of you were not there in my session on Wednesday? Okay, I see 3 or 4 of you. So since this is being recorded, I'm also going to talk about the key value proposition of Columnstore, which takes 10 minutes. It'll be a repeat for those who were there with me on Wednesday, so allow me for that. Now, the success stories is something that we are really proud of, because it's one way to create the technology, but the most satisfaction we get as a product team when people are using this technology to solve their business problems. So what we did was, I've been working with many customers on this technology. So what I chose was picked 4 scenarios which are very different, okay? And the impression that I want to leave you with is that Columnstore is just not one-dimensional. You need to think outside the box to see how I can leverage this technology for my workload. So that's the goal, right? So what I'm going to talk about is the overview for some of you who are new to this technology. And the customers that I've chosen is Damon Health. Let's see if this works. Okay, I think the battery is out, so that's okay. Let me, you know what, I got something, just hold on. Is it reaching? Okay, so this is working. I always have a backup. All right, so the first company that I'm going to talk about is the Damon Health Insurance. It's a health insurance company in United Emirates. And they actually, as you can imagine, they have a lot of patient data. And they manage multiple hospitals. So they want to figure out how customers are using, how their insured patients are using services, what is the average rate they live in the hospital, stuff like that. They do a lot of analytics on that. So that's that example. The second example is the First American title. This is a real estate company in Los Angeles. And this is one example where we did not think, I mean, when they came to us, we did not think Columnstore will be useful. And we tried it. And it worked like a charm. So that is one scenario like that. The third one is the M-Files. It is a competition to SharePoint. How many of you use SharePoint? Okay. The biggest challenge with SharePoint is you store the file in some directory, and now if you want to reference the same file from different categories, it becomes very hard. And M-Files actually has solved that problem. So they load the data, load the files, and they maintain a lot of metadata. And they want to do a lot of analytics on that metadata. So I want to show you that. And the final one is a FIS. This is a financial company. It's a FIS Global. And what they have is they have these stock traders who are trading the securities, and they want to do some analytics on that. So those are the 4 examples, right? Audiences, I mean, we don't have a whole lot of people. Please ask as many questions as you want. I will try to respond. I should be able to finish all these things in 60, 65 minutes without the questions. Okay. So the first question is, where is my clicker? This is, as I said, repeat. So what is the value proposition? And for those who are new here, and just allow me for doing the demo. So the Columnstore technology is a new storage format. I hope I don't forget my password. Sorry. Okay. It's a new storage format that was introduced in 2012, all right? And we have been improving this technology release after release, 14 and then 16, right? So at a very high level, if you look at our data warehouses, right? people create the data warehouse with a star schema, right? You have a fact table, and you have multiple dimension tables. Is that something you guys have experienced in your organizations, right? Fact table, those kind of things. So the people, before Columnstore came along, people were doing analytics in two ways. They were using page compression if you were using SQL Server to compress the data well, because analytics is very I/O bound. Or they were doing analytics using the cubes and the pre-aggregation, because the SQL Server or the relational systems as is, without the Columnstore, could not deliver the performance they wanted, right? So that was the thing. So I want to show you an example here, and where I'm running a complex query. Here's a query, and what you will see is that there is a fact table, right? This is the fact reseller table, and it is joining with 3 other dimension tables. It's a very typical analytics query that you will do, okay? So I'm going to run this query. This query is running where the fact table and the dimension tables are all in row store, right, without the column store. So this query takes around 35, 40 seconds. And what I want to do is we will convert this fact table, which is row store, into a column store table. And the way you do it is a DDL operation. You say create column store index on the fact table. That's what you do. Now, if you already had a cluster index on the table, if you already had a cluster index on the table, what you do is you say create clustered column store index, drop existing, right? You just drop the row store storage and say I'm going to create a column store. So what it does, behind the scenes, SQL Server will convert the row store into the column store. So it took around 39 seconds, right? So let's say we did that, because it will take some time, because compressing the rows is not a cheap operation. When we do that, so this is the example I give, right? You say create cluster column store index on this table. So I just did that, right? And for this presentation, I already have the index. So I'm going to run the same query, okay? The only difference that I want to show you is that the fact table is using the clustered column store index, right? I just have 2 copies of the table, exact same data, right? So I'm just going to run that query. And you will see this query runs in 2 or 3 seconds, right? It ran in this example in 3 seconds. So this indeed is the power of column store technology, where without changing the application, you can improve your analytics multifold, okay? This is on my laptop, 4-core machine. I get 13 times better performance. In server machines, in many customer cases, we have seen up to 100x improvement for some queries, not for all, right? Some queries. Now, the beauty of this one is, if I can get 40 times or 30 times better performance without really changing anything, people are saying, why should I do aggregates? Why should I do cubes, right? I can run the queries, right? So that's the power of this technology, all right? And the beauty is, not only you get good query performance, you also get significant storage savings, because column store compresses far superior than page compression or the row compression. Column store is a highly compressible storage format, okay? And one thing I want to emphasize, this is not a Microsoft technology. Column store is not. Column store came out of universities. Everybody, Oracle, HANA, Sybase, DB2, they have adopted this technology to improve the performance of analytics. And the reason I want to say that is, I want to show you a benchmark that is the NC Council. This is like a standard committee that do a benchmark, and you will see the implementation that SQL Server has done for column store is the best at this time. I mean, things are moving, right? It is the best. And I think, so it is important to know that with SQL Server, you are working with the column store technology, which is the leading technology in the industry, right? That's one point. Okay. So not only I get good query performance, if I look at the storage saved, you will see that the first line is the row store. It is taking approximately, let me just do this, Control 1. No, what happened? Hold on. Let me do this, F5. I'm just trying to showcase here. What happened? In just a second. Sorry. I think I lost something. But the thing is, here, if you look at, that it is 2.5 gigabyte in row store. And if you go to the column store, I got around 700 megabytes. Okay? So what you get is amazing performance and significant reduction in the storage, right? It's like both wins, right? You not only reduce the size of the database, you get better performance, right? So that's the power of this technology. All right. So I'm going to switch back to the presentation. So that is the key value proposition. And then this actually, you can go, this is not something that Microsoft has published. This is from the ANSI standard benchmark website, the TPCH benchmark. TPCH is the analytics benchmark that has been there for 15, 20 years, right? And what you will see is that the column store from SQL Server, right? If you see this column store from SQL Server is leading the last 5 or 6 benchmarks, okay? Other important thing to note is, remember, this is 2014 and this is 2016, right? So we have been leading the TPCH benchmark starting with SQL Server 2014, okay? And this is huge, right? The next competition to us is Oracle, which is sitting at the 7th or 8th position, right? Now this is a S&P benchmark. I'm not talking about scale out benchmark. This is the S&P benchmark, okay? And so we are leading, number 1, right? And this benchmark that was done, if you look at the top, it was 10 terabyte database, and this is 30 terabytes, S&P box. So if you have databases 30 terabytes, you could run them with Columnstore in the word record implementation on a S&P box. It's pretty huge, right? Anybody has data warehouse larger than 30 terabytes today? Okay. Nobody, right? So I'm saying you can run that on S&P box, and you should be rest assured that you are working with a technology that is leading in the marketplace, okay? So now, because it is such a winning technology for us, we have been investing in this technology. And this is just one slider to show you what all we have done. So we have worked to improve the column store query performance without requiring any changes to the application. So you move from 14 to 16, you should see improvements for most queries, right? So that is something we did. We added new functionality. We added functionality like non-cluster index on the column store. And we talked about that on Wednesday. It allows us to do a enforcement of primary key, foreign key if I want to do that. It allows me to do a short range queries or equality queries very efficiently. It allows me to do row level locking in a operation. If I'm updating some rows, in 2014 update was taking the lock at a much higher granularity, but now I can do row level locking, right? So all those things are there just by upgrading to 2016. And we have also support now, support for RCSI, which is a read committed snapshot isolation level, non-blocking read. So what it means is when you're running your queries on your database, it will not block writers, or writers will not block this query, right? So this is actually pretty much available to you. The third thing that we have done is the real-time operational analytics. And this is something I'm going to take a minute. This is like a 1-hour presentation, but I'm going to take a minute what it means. You know, you have analytics workload, right? So we are saying for those workloads, just create a clustered column store index, okay? You just create a cluster column store index, you're done. There are second category of applications, which is your transactional application, right? You're running your OLTP workload. And most of the time, what people do, they extract the data from the transactional system, right? Do some transformations, and then store into the data warehouse, right? So for many workloads, not all, what we are saying to them is, instead of doing the ETL and separate data warehouse, you create, and mind my word here, non-clustered column store index. Not the cluster, the non-clustered. So it is a new index on the same table. So your transactional workload will work like before, and your analytics will speed up because you have a column store index on it, okay? So those are the very high-level changes that we did. Now, if you run the same benchmark, the TPCH benchmark that we did with 2014, what you will see is the first line over there, same hardware. What we did was we ran the same hardware, and we see 40% improvement in the performance over 2014, again, without requiring changes, right? Now, this is a workload. This is not your workload, right? That means when you go to 2016 from 2014, you may get 40% or more or less, right? But the point is that if you just measure from an objective level, we are seeing a 40% gain using this benchmark, again, without requiring any changes, right? Any questions? Okay. So what I've decided, I have 4 customer cases. One is a traditional data warehouse, okay? So this customer is as I said, they are a health insurance company, and they are located in United Emirates. And what they had was a traditional data warehouse with 100 tables, all right? And some of those tables have billions of rows. I mean, this is very typical case. You have data warehouse with billions of rows, right? And what they have is a very complex data flow. So what you will see is that they are getting data from, so I don't know whether you will see the clicker or not, but I think I'll show here. They're getting data from source systems. It goes through a huge level of transformations, and finally it lands into this UDM, which is their data warehouse. Okay, this is where the data lands, and then they have these analytic queries that are running on this database. So that's the solution they have today, or before they move to SQL 16. So that's the solution. Okay, and the queries they were running, this is a typical query they run. The red thing that you see is the fact table, and other tables are the dimension tables, right? These are fact tables, and these are dimension tables. So that's a typical query that is doing a join, 2 joins. Actually, if you can look at it, like it is doing some filtering, and 1, 2, 3, 4 or 5 joins. That's a typical query they want to run. Okay. The second query, which is even more complex, it is this, where they are running a 3 fact tables, multiple dimension tables. So it's a complex query, all right? And they were running this solution on Sybase 15. They were using the solution, and they built that solution 3 or 4 years ago, and they've been running on that. And they were happy. They were happy. But what they were finding was that their data is growing because their business is doing well, their data is growing. So there comes a point where the current solution could not meet the SLA they had for their analytics. Okay? So that was one big problem. And of course, analytics for them is money, because the more insight they can get, the better decision they can make about patients in the hospitals and things like that, because they want to manage the cost of the patient care and the hospitals, what they charge, and end of the day to provide a much better service to their customers. Okay. So the challenge was that the current implementation did not meet their data growth requirement, and they were saying the data is going to grow for me for next 3 to 5 years. What do I do? Okay. Yes, they could have upgraded to Sybase 16, and they were thinking about that. So they hired this company from Switzerland to help them take their data warehouse to the next level. Okay. So that company was hired, and what they did was they worked with them, and they said, you know what we should do? If you are looking for a solution that is going to grow with the data, right, and deliver the performance, we will evaluate 6 competitive technologies. Okay, so they had the luxury of time. So the green box that you are seeing over there, they are actually evaluated 6 competitive technologies, right? And the way they did that was they took I would not say sample, they took a representative schema which they were running in the production. They brought that schema and the data, and they replicated that 6 times. Okay, and they said, let's figure out which of the technologies will give me the best performance. Okay, so when they did this POC, they found that 2016 with Columnstore was the best performance. Okay, so they actually once they decided that, then they said, since it was a sample schema, sample data, I want to run in exact production like data. Okay, so what they did was, in the middle thing that you may not see very well here, they actually moved this. I'm talking about this guy. This guy. So they started running Sybase, current solution, and 2016 in test environment. And what they did was, they got the same data loaded into them in parallel as data is coming in. And analytics were running queries on Sybase as well as on SQL Server, right, in the test environment. And they found that the response time that SQL Server 16 provided to them was meeting their SLA. So they were convinced that this is the right solution for them. So then they basically dropped Sybase and moved to 2016 as a solution, all right? So that's what they did. So the solution, as I said, was using clustered column store index. And they used, with that cluster column store index, one non-clustered B-tree index. And this is important because you could not create a B-tree index on cluster column store index. I'm saying big words here, in 2014, okay? Because think about this, right? There is no pure data warehouse in real life. You do analytics, you may do some equality searches, you may do many things, right? Because we could do a non-cluster index on cluster column store index, allowed the customer to run wide variety of queries in a more efficient way. Yes, sir. Right. So the question is, if my dimension table has, say, 100,000 rows, should I create cluster column store index on it or not, right? The column store index has a threshold of million rows. Okay, we only compress after a million rows. Okay, so typically we do not recommend using a column store index on tables with less than million rows, right? Having said that, there are places where it has given benefit. So what we do, we tell our customers is to compress by force. So you say insert 1,000 or 100,000 rows into your dimension table. You can say alter index compress. It will compress those rows into compressed format, and you can get better performance, right? Okay. So that was a solution. And what I'm going to show you is something pretty amazing, okay? I'm just going to build this up. Okay. So you see those 6 vertical lines? These were the 6 competitors they evaluated. Remember they did a POC? They evaluated the 6 products, okay? So I'm just going to talk about the left chart first. You know, at the bottom, you see the light blue. This is a big query, right? Remember there were 2 queries. One was a simpler query, one was a bigger query. The query on the leftmost column is the performance 2.1 minutes on SQL 16, okay? 2.1 minutes. If you look at the second blue item just before the big red item, it is on 2014 cluster column store index. That means for this customer, the 16 column store gave them much better performance than what they could get on 14, right? Same kind of point. And here it took like 25, I can't see from there, let me just see here. It is around 25 minutes, right? It's like 10 to 15 times better performance, right? So that's that. And then the orange and the green and the red, these were the numbers for our competition. Now I cannot name those competition because we cannot say that in public format. But these competitors exist on this planet. They are not from a different planet, right? I mean, you can think of whoever you can think of, they are here, the big guys. We beat everybody hands down with 2016, okay? The other one, the 2000, like a typical user query, which was a simpler query, right? Again, notice, I'm looking at the second column now, the 1.1 second, I think, let me get my clicker. Let me get my clicker here. See this guy? This is 2016, 1.1 second. 2014 is 4.1, and everything else, right, is higher than 2016. But notice one thing. This green guy, I can't tell you who that guy is. They were better than us with 2014. They were better than us. But now, with 2016, they're not, right? So what I'm saying is with 2016, we can pretty much, for this workload, right, beat anybody hands down. You also saw the benchmark. Okay. And this migration to 2016 for them literally took 10 weeks, okay? Because they just have to move the data, do a lot of testing, stuff like that, and they were so happy. And okay, question? Sorry? Which one?
Your competitors, other
Right, competitors.
similar concepts.
That's right.
So this performance, did you also enable that kind of optimization properly, get the result?
Right. So this consulting company that they hired, their job was to make each of those competition work the best. It was not like tick mark item. They really had the expertise to optimize each of those competition. In fact, like for example, for SQL Server, they worked with me, okay? For others, they worked with their experts to make sure we get the best numbers. So I believe it is very fair comparison, right? So this is the number they have seen. They have queries that they run in the daily mode, and they saw a significant improvement with SQL 16. And if you notice this box, it says hundreds of hundreds of queries, and with 30 concurrent users, right? And many queries ran under 20 seconds, and they were pretty much happy with that part. They had weekly reports that were running on Sybase first, and then they moved to 2016. And what you see is they saw a 60% improvement in those queries. And on monthly ones, they saw 5 times improvement. So the point is, after all the testing was done, they had the benchmarks, what it was before and what it is after 2016, and they saw such a huge improvement, right? So what I'm going to show you, I had presented this at Ignite in US. So the gentleman who did the migration was on stage with me. So I'm going to play a recording of, he logged in to Damon's production system to run the queries. I'm just going to show you the demo. It's going to take like 3 or 4 minutes. I think it's a pretty compelling one. So I go here and okay, so this is the live demo. He logged in from the conference room to them, and I'm just going to play here.
Has over 200 million rows. So that's the kind of data volumes we are talking. I show you, to begin with a query on the largest table. So we are joining a fact with 2.75 billion rows with 2 small dimensions. One has around 100,000 rows, and the other one has around 100 or so rows. And we're basically doing slicing and dicing live with these couple of tables. So I'm aggregating 2 orthogonal dimensions and seeing what it looks like. We're done. We have around 3 seconds.
Isn't that phenomenal?
I mean, I wouldn't dare run this query with a previous solution. Okay, so the next one is a little bit more complicated. We have a claim table with around 200 million rows. With this resolution, you can't see the full query, but basically you see it's involving lots of joins. And what I'm doing again, I kick it off, I'm aggregating data across a few dimensions, and the biggest of this dimension has 20 million rows. And while I'm talking, the results are actually already there. So again, a few seconds, which I think is pretty good.
So I'm going to stop there because you can see they were running pretty mean queries, right, on 2.2 billion row tables, and it was coming back like in seconds, right? So that's the production experience for this customer. And so we were actually pretty excited, and they in fact are going to do a case study with us, and it should be published very soon. And I'm going to send it out to the organizers in Ignite here, and they can give it out to whoever is interested. Or you can reach out to me, I'll send it to you. Okay, so the learnings, some of the interesting learnings were, they actually were doing a lot of ETL, right? The data was, they used to update a lot of information, they used to delete and insert. So as you can imagine, the column store index is not really conducive to high scale updates and deletes. So we did some tricks. We said, okay, we will batch the deletes. And basically what we did was we broke update into delete and insert, and then batched all deletes one time, and then ran all inserts one time. And that's how we were able to get very good performance for ETL. If we were going to do update one row at a time, we would be in trouble. So that's what we did for them. Optimizer. Okay, this is something I think I want to emphasize here. Do you guys know the cardinality estimator? Anybody knows cardinality estimator? Okay, one person. You know, like SQL Server Optimizer, when it is optimizing the queries, it has to estimate when I do this predicate on this table, how many rows I'll get, right? How many rows I'll get here, I do a join, stuff like that, right? That the estimator, that is the cardinality estimator. There are two estimators in SQL Server team today. One is the old one that we were using before 2014, and the one that we are using after 2014, also in 16. And what we are finding is many customers, the workload runs better if they were using old estimator, okay? Some customers find new estimator is better, so it's one of those things. In their case, they had to go to the old estimator to get the results they want, okay? That is something important. And they actually were using this NCI on CCI, that is non-cluster index on cluster column store index. And they found a couple of bugs for us because they were doing this testing before RTM was done. They were running in a pretty high-end ETL scenarios, and we found sometimes rows were missing, and we fixed that problem. So that was very good. Okay. So that's what they did. And one thing I want to say, this is actually I forgot to mention on Wednesday. You know, when you create a index on a table, let's say I'm creating an index, a traditional index on table T1 on column C1, let's say that. Because when we create the index, we need to sort the data, right? The statistics get created at the time of index creation, okay? When you create a column store index, since there is no key column, there is no statistics. So first time when you run the query on column store index, it will run slow because it has to build the statistics behind the scene, right? And if you have billions of rows, it will run slow. So what we tell our customers is that if you want to hit the ground running, just build the statistics after you create the column store index, okay? So that is other thing. So that was a traditional data warehouse scenario. You saw the impact they had is pretty mind-boggling to us. The second one was a real estate property search. In US, if you actually, this is US solution, there are 150 million properties in US, okay? So now imagine this, right? If you are in the market to buy the property, you are going to say search in wherever I'm living, in this price range, 2 bedrooms, backyard. I mean, you see what I'm saying? So you need to do all those kind of queries. This database that they had, it's only a single table. They had 150 columns. That means 150 criterias that you can use to filter the properties. Okay, so they had that many things. And as I said, the search criteria, they had a web application. You can say where, whatever you can say, like they can 10 predicates, 15 predicates, and those predicates were not fixed on certain columns. You could do a predicate on any of those 150 columns, right? So that was a challenge, 150 million rows and all that information, okay? Now, what they wanted was that when I run this query, I should be able to find the list of properties very quickly, okay? If it takes 15 minutes, 10 minutes, people will not use the application, right? Okay. So that's what they wanted to do. So this is not a data warehouse scenario, right? You would agree, this is not data warehouse. This is like you are doing selects with like all kinds of predicates. And interestingly, they were modifying approximately 1 million rows per day. Why? Because think about this, right? Anytime the tax changes on the house, that row has to be updated. So they were updating million rows a day, updates, not inserts. So it was again something challenging for the column store. So we said, well, this is not a column store scenario. In fact, they were using SQL Server 2014 and they were not using column store to solve this problem. Okay. So what they were struggling with was, you know what? I get lots of queries, but these are the most common queries. So they picked like 20 queries that were the most common. Then they said what they will do, they will make those queries go faster by creating non-cluster indexes on the row store, right? You create the non-cluster indexes and the query will go faster. But if the query was issued in such a way that there was no index, query will run slow, right? So now the thing is, you know, somebody can say, you know what, why don't you create a non-cluster index on all columns? Like there will be 150 columns. You could do that. You know, the fallacy of that thing is, I'm sure you all know, if I have 150 column non-cluster indexes, you can kiss your ETL goodbye. I mean, ETL will die. I mean, right? Each row update, right? So that was not a solution. So they were in a fix. They said, what do we do now? Okay. So when we joined with them, they were evaluating multiple solutions outside of SQL Server to say we need to solve this problem, and they know the row store is not solving their problem. All right. So their success criteria was that 95% queries must come back under 5 seconds, and none of the queries should take more than 10 seconds. That was the criteria. Okay. And it should be able to support 400 concurrent users. So they just gave us, this is our benchmark. We said, fine. Why don't you give us the queries? They gave us around 120 queries. And we said, we will run the query with the whole concurrency thing and measure the performance. So that's what they gave us. So this is an example of a query. Let me see if I can make it a little bigger. So this is like searching for some select list property where, you know, home equity is 50%, decent mortgage. I think I'm going to go back here. You see what I'm saying, right? So these are the kind of queries they were running, and this query was running 8 minutes on 150 million rows, right, in their current solution. This is another query that, again, searching for the street number so-and-so in Los Angeles and whatever not. It was running in 10 seconds. This is just 2 examples of the queries that they gave us, and this is how they were performing on the row store, right? So the solution that we came up for them was, why don't you keep the row store as is, okay? So this yellow guy that you see is a row store, okay? They kept the row store as is. They kept the B-tree indexes as is, just like before, okay? And what they did was, they also had a full text index. They also had a spatial index, because what they can even do in their application, you draw a map, say, I want to find properties in this area, right? So they had a spatial index also. So we could do all those things on the row store, right? This is supported. This is what they were doing today. Then we said to them was, you just create a non-clustered column store index on it. Okay. Now the beauty is, all analytics will go to the column store index behind the scene by the optimizer, and everything should just work like before. So this is what the solution they got. And of course, in this case, because column store index does not support spatial indexes, it does not support large text columns. So we excluded those columns from the non-cluster column store index, because those columns were not part of analytics, right? So that's what we did for this solution. And as I said, optimizer chose the right index. And by doing this, we ran the benchmarks and we met their SLA. And they were so excited, right? Hey, we don't have to move to any other platform. We will stick to SQL Server. But one challenge, you know, this is a company, they did not want to move to 2016 right away. They have a, you know, process. I'm sure some of you have the same kind of process. It takes 6 to 8 months before they will adopt SQL 16. Okay. So we said, okay, now what do we do? Because we don't have a non-cluster column store index that is updatable in 2014. So what they did was, they created a cluster column store index only the columns that were supported in Columnstore index, which is no text, no spatial index, and they created a separate row store. So essentially they had two copies. One copy was sitting in Columnstore and one copy was sitting in the row store. Okay? And what they did was they built the full text index and the spatial index on the row store. Got it? And then they put a layer on top of it. So when the queries are coming, the hybrid layer will figure out, should I go to the cluster Columnstore index or should I go to the row store? And that's how they implemented the solution in 2014. Okay, that's how they got it. And this is what I just talked about. So this is the kind of queries they were running. At the bottom, which you see the nested query, this is the query that was running inside Columnstore index, and the one above was running in the row store. So the key point is the layer that they had the smarts built in, and they told us it took them literally 2 weeks to put that layer on the top. Okay? So by doing this, they were getting the SLA they want, and I'll show you something. With the database size, I'm not talking about the row store separately because row store is the full row store. They were able to compress with Columnstore index 13 times, like from 560 gigabyte, they went to 44 gigabyte. It's pretty huge for them. The CPU consumption, they were running at 23% in your old solution, they went to 7%. Now, this is average, but they have peaks and valleys. So they were very happy to see that the CPU utilization went down to 7% on average. That means if the peaks and valleys come, they can scale better, right? So that's what they got. And they ran the queries with 100 concurrent users. On average, the query went from 2 minutes to 2 seconds, almost like 100x or 70x. Right, so that was the whole solution. Now, the thing that I want to emphasize to you is that like we were learning about Columnstore technology. We never thought the Columnstore is the right solution for this one. We were, in fact, trying different things. And then we said, why don't we just try Columnstore? Because we were concerned about the ETL, like million updates per day, which was huge. We were not sure because Columnstore is mostly good about aggregates, right? But when you're looking for the property, you're not doing aggregates. You are saying, show me the properties that meets this criteria. Select star from, you see what I'm saying? So it was not really a Columnstore kind of queries, and we did that. So that's the pretty amazing number we got. And they are live in production, and they're pretty happy with us. So that was another example. So the third example I want to show you is the, in their learning. I think learning I just talked about in the sense, just because Columnstore does not support something, you have to think outside the box. What can I do to make it happen? And it can work out, right? So that's what they did. Imagine this in their case, right? They had a different row store, 2 copies of the data. They're doing 2 ETLs, right? They're saying that's not the problem for them. The storage was not a problem for them. Problem was the query performance, right? And then, so you may ask me this question. This is actually a very interesting point. Remember, there are 150 columns, and you can do predicate on any column. So how does it work with Columnstore? How does it work with Columnstore? Okay. The point is, Columnstore has these row groups, right? We have million rows row groups. And for each column, we maintain the min and the max. Okay, so when these predicates come, actually SQL Server was able to very narrow down which row group will be the right row group to meet their query. Okay, we were able to do that. Okay, we tried another solution for them was, why don't we break the properties by the state? We partition by the state, because if I'm living in Australia, or like if I'm living in state 1, I think this is Queensland, right? This state. If I'm in Queensland, most likely I will be looking for properties in Queensland. Why would I be looking for properties somewhere else, right? So they tried the partitioning solution as well, but they were saying if without partition they're getting good performance, they think just leave us alone. So that's what they did. Okay. All right. So this, the scenario that I have now is HTAP. HTAP means operational analytics. So this customer is a financial customer, and they actually what they do is, like I don't know much about financial industry. Okay, so basically what they have is they lend securities to these other buyers, not buyer like you and me. Those are stock traders. They lend securities short term. So So they do a lot of these transactions, the OLTP workload, that all, suppose for example, Microsoft stock is selling, something else is selling, all those prices are coming into their system in the real time, and they are figuring out what is the right price for me to sell for this lending, for this security. So I may not be able to do a good job in explaining what the scenario was, but the point was they have a lot of this OLTP kind of workload, and they also wanted to run analytics on how the security is selling, what is the right price I need to set, stuff like that, right? So they wanted to do OLTP and analytics at the same time, right? So this is a solution they had on SQL 12. What happened here? Right. So the current solution was using SQL Server 2012, and for analytics, they had an ETL. They had an ETL every 5 minutes, okay, into a separate data warehouse, and so they can provide the analytics. So their traders were saying, in stock trading, each second counts. They said, I don't want 5 minutes. I want analytics to be done in the real time, okay? And also, if you run that analytics in real time on your row store, your transactional performance will be messed up, right? And also, as I showed you, row store does not do good analytics, right? It slows down. So they were in a soup. They said, what do I do now? The interesting thing for them was they had at peak 1.2 million rows. So they start this day. They start every day with 0 rows because today's trading, not yesterday's. They start every day with 0 rows, and by the end of the day, they get 1.2 million rows. So that's what they got. So the question was, Columnstore, like I told you about, you can only get compression benefits after you exceed 1 million rows, right? So we said, I just don't know. Columnstore will not be useful, So what could we do? How do we solve their problem? Okay. You are with me on this one? So, the thing was, when they came to us, and I said, well, Columnstore will not work because you have very small set of rows. So we said, okay, so what we will do, we will test 2 configurations. We will configure in-memory OLTP, okay, in-memory OLTP with Columnstore, and we will also test a row store, which is what they had, traditional row store with Columnstore index, non-clustered Columnstore index on top. So we said, let's just go with those 2, okay. We tried those 2 solutions, and we said, let's do a baseline. Let's just load the data, 1.2 million rows for the day, and run the compression. So everything got compressed, and let's say now you run your analytics and see if it can meet your SLA, okay. So what they do is they run analytics. So it's like this, think of this, you are a trader, you have a screen. That screen has lots of frames, and each frame gets filled in by these queries that are running, analytics queries that are running on this system. So they were running around 14 queries on that system, and they wanted to deliver that screen in 3 seconds, okay. That was the deal. So we said, okay, so we created a non-clustered Columnstore index. We found that the transactional workload did not impact. So they were happy that my transactional workload is not impacting, but the analytics performance was slow because data was not getting compressed, right? So we said, okay, let's compress the data and at least prove to ourselves that Columnstore will meet their 3-second SLA, okay? So that they met. So they were happy. So now the question was, what do I do? Because I'm starting every day with 0 rows. I don't see compression until like 2 hours before the market closing, right? So I'm suffering the whole day, and you give me a relief only for the last 2 hours. So what we did, we said we will force compression after every 100,000 rows, okay? So 1.2 million rows, so they got 12 compressed row groups. So what they do is, every hour, they say approximately 100,000 rows come every hour. I'm going to run the script, compress. So whatever was sitting in our delta row group, row store, we will compress them, right? And what they found by doing this, query performance was not as good when everything was fully compressed at the same time, but it still met their SLA, okay? And they were so happy with this number. They got very similar number with in-memory OLTP as well. But they said, since I already use row store, I'm not using in-memory OLTP. I'm just going to just stay with my traditional row store, no in-memory OLTP, with a Columnstore index on top. Yes, sir. Right. So the question is, when you compress the data, 100,000 rows, compression does not come for free, right? It takes CPU resources. So yeah, there is a little bit dips here and there, right? But they can compensate that by adding more CPU power, because that is the least of the problem. The problem was they wanted to run analytics in real time. So now by doing this solution, there is no ETL anymore, right? So their traders are extremely happy. They are actually in production with this system, and I'm going to give you a code on this one. Okay. So okay. So the number that I want to show you, let me see if I can go bigger here. So what you see here is on the first column is NCCI, right? You see 10 milliseconds. With the row store, it was 180 milliseconds. So it is a gain of 18.5. You can see across all the queries, they got huge gains. Okay. And the reason I'm saying all these queries are important, because these queries were delivering content for each of the frames that the trader had on their screen, right? Right. So they were pretty excited. Hey, this is all set for them. And if you look at the dips, I think the dip that you were just asking me about, so they ran the workload. The green line at the bottom is what they are getting with the NCCI. The blue line on the top is with the row store. And the fluctuation that you see is that compression that is happening in between. So they were pretty happy with the performance. Okay. They moved to production, and they were, as I said, I mean, they were pretty excited about the whole thing. And this is the link to the case study. If you get the slides, you can just click on it, and it is there. And this is the exact quote from their vice president. He said, with the non-cluster column store index, we did not have to involve our DBA. I mean, I won't recommend that. I mean, I will not create an index without talking to my DBA. And their queries ran 4 times, 10 times, even 20 times faster. So, yeah. Yeah. Right. So the question is, why did we choose 100,000? It was just a starting point. Yeah. We could have said, let's do every half an hour. We could have done that, right? But 100,000 just worked out well. It's just a good number. Yeah. I think the reason I chose 100,000, to be honest, because when you bulk load data into a column store, we say if the batch size is 100,000 or more, we will compress them, because that's the ideal size for us to compress. The minimum size that we want to compress is 100,000 rows. So that's why I chose 100,000. Yeah. But again, the point I'm making to you is important, that you need to think outside the box, right? How do I make this thing well, right? And the only way I did this was, we said, let's compress the thing and see what is the baseline we get. If we are good there, then we'll figure out what's the best way to do it, right? Okay. Any questions other than? Oh, there's a question. So the question is, once the data is compressed, is it read-only, and can we update that? And I know the confusion in this question. The thing is, once you compress the column store, that becomes read-only. Okay. So the question is, how do you update something? So what we do is, we create a structure called deleted row structure. We keep track of the rows. Suppose I want to update something, we do it as delete, insert. So we keep a separate structure behind the scene, which tracks how many rows were deleted, and we insert the new row, right? So let's say a row was compressed, and you want to update that row. We will mark that row as deleted, okay, and insert the updated copy. Yeah. Let's say I have 10 column table. I update only column C1. We will mark the row as deleted and insert the full row, that C1 updated column, and all the 9 values from the previous values. Okay. So think of this as a delete insert. Okay, that's how we do the update. And in their example, they were not doing that many updates, because the securities were coming in, right? So this is a solution as live in production with them. The final one that I want to show you is the M files. And what M files was, the SharePoint I was talking about. In the SharePoint, when you store the data, the files are sitting in a directory. you have to go to that directory structure to figure out the files, right? And it's a painful thing. Like in our organization, I mean our group, we have documents, but we want the same document to be visible under different categories, okay? But we can't do that easily. So M-Files is a company out of Austria, I think, and what they did was they said they will organize the information based on what, not where, okay? So they store the files, the text documents, in a monolithic directory, okay? And what they do, they annotate the document with some meta information, which is the metadata, all right? And they store that metadata into SQL Server tables. Documents are not in SQL Server table. Metadata is, okay? And then, based on how you categorize, it will figure out which file will meet this criteria. So that's what they have done. So what is important to their customers, not where it is stored, right? Okay. So here is an example, right? You have a document that you are uploading, like SharePoint, I upload a document. So what they do is, when they upload this document, because they are creating a lot of metadata, each update or upload of a document means 60 inserts into their meta tables. Okay? So you upload the document, 60 inserts have to happen somewhere. So the point I'm trying to make to you is, it's like a OLTP workload. You're doing a lot of inserts, okay? So that's what they do. If you want to make changes to the document, right? Suppose I change the categorization, I change something, it means the 60 rows that I inserted, they need to be updated, right? So they're doing lots of inserts, lots of updates in their documents. And then you can, like the thing that I'm showing you on the left side, now depending on what the view you want to see your documents in, you can categorize them differently. These are like different kinds of categorizations. The same document can be referenced in the different categories, okay? So that's what they are providing to their customers, okay? So the key thing is, when they show all these things, they also do some analytics. I'm going to show you an analytics example, but the key point is they are doing a lot of inserts and updates and deletes, and they do some analytics. So this is their problem, this is their solution. The requirement was that when I insert or update my document, it should finish in 1 second or less. It should be that instantaneous, okay? So that is the requirement from a transaction perspective, right? Because if I'm inserting a document, uploading a document, I need to do 60 inserts. It should finish in 1 second or less. That was their requirement. Mass updates should be under 3 seconds, okay? And when they want to categorize listings, for example, you want to do analytics saying how many documents of this type updated, like some analytics kind of queries, they should run in real time. So they had this requirement, not only you do upload and changes of the document, but I should be able to do analytics on those documents in real time, right? So they, in fact, did not have an ETL scenario. They were running on row store with this solution, okay? And they were live in production. They've been running happily. Now, the challenge they had was that they were not able to meet their SLA as number of documents started growing, because their service became very popular and more documents are coming, and they were, as you can imagine, right, the query performance for analytics is a function of how much data I need to munch, right? If I have 10 rows, everybody's happy. But if I have a billion rows, there's a problem, right? So as data was growing, they were not able to do it. So the workaround, they said to their customers, well, if you have more than 10 million objects, we do not support you, or do some other tricks, because we could not deliver the SLA if you have more than 10 million documents. And that was a big issue for them, because their goal was to support up to 100 million documents for their customers in 2 to 3 years time frame, right? And they also debated, should we move the analytics to a separate ETL kind of scenario? And they said that's not the option for them. They want in real time, okay? So as I said, they had the real-time analytics before Columnstore came along, but their hands were tied because they could not do, if the number of documents exceeded 10 million documents, their SLAs were all over the map, right? So that was the problem they came up with. So what we do was, so before they came to us, they evaluated Hadoop, HP Vertica, and NoSQL solutions because they were desperate. Because it was, I mean, for them, the business will die. I mean, if I can't support that level of documents, right? So they evaluated all these things, and we got engaged with them as part of SQL Tiger team in the POC. So they contacted us. He said, "This is my challenge. What could you do for us?" Okay. Now, in this case, I immediately thought of non-cluster column store index. I said, "You're doing analytics, you're doing transactional workload, so let's try that solution." So we thought of that solution. And in this case, they, like Hadoop solution or the NoSQL solution, they were not transactional. They were not giving the ACID property. Like the SQL relational database systems are atomic, consistent, all those things. They wanted that kind of a guarantee. And their customers were running either on premise or in the cloud. So what they do is they ship their product. You can install in your site, or they also provide a service in the cloud where you can upload your document in the cloud and you can do that. So they wanted a solution that works not only on premise but on the cloud. So those were the things they were looking for, and they decided to use the non-cluster column store index with 2016 to solve their problem. And the beauty was there was no application change needed, because all they did was, the table was there, everything was like before. They just created a non-cluster column store index, okay? And which I did not point out here, they in fact dropped some indexes because they were not useful, because they had created those indexes before column store index came about to improve the queries, right? But now, since I put in the column store index, the big daddy of queries, yeah, some of those indexes were not needed, right? So they dropped that index. And this is how their solution looks like. I'm just showing a very pictorial way, right? The blue thing at the the red thing at the bottom is the non-cluster column store index. And SQL Server did the magic. Behind the scene, when you run the analytics, it will go to the column store. Otherwise, it goes there. Now, it is easy for me to say. I'm sure when you run non-cluster column store index in your environment, you may find some queries are choosing the wrong index, right? I mean, we, of course, are trying to fine-tune that. And I think if you guys use it, find an issue, we'll try to fix it. But the point is, it is heuristic-based, right? So that's what they did. And notice what they got. The environment they tested was, remember we were testing with the 10 to 15 million rows because that's what they could support. They had the benchmark with 77 million rows and 5 tables involved in the query, right? And the performance, because they were concerned, because when I created a non-cluster column store index, what is the impact on my performance for my transactional workload? Remember, when I upload a document, I have to insert how many rows? 60 rows, right? So what is the impact? And they found the transactional impact was only 5%. And that was okay for them. I mean, I would like to have zero impact, but 5% is pretty good. And this is the performance they got. I mean, if you look at the red column, 6.5 seconds on the row store and 0.5 seconds after moving to NCCI. The second line is even more impressive. It was 2.6 seconds before and 0.05 now. 0.05 means 20, 40, is like 40, I think 40 plus X gain, right? So they were pretty happy with this. And the query, remember the query I'm talking about? This is an example of the query. This is a pretty mean query, right? Don't think it is like select something. No, it was a big query, okay? These are the queries I'm talking about that ran in this kind of time, okay? So the problem solved for them because the transactional workload is working fine, analytics solved this one, right? And this is the exact quote from their founder, Mr. Antti Nivala. Lightning fast, right? If you look at 10x faster query performance for critical workloads and no code changes, right? So they are live in production, and they are one of our customers who are going to do case study with us. We are working with them on the case study, right? So this is another example for this workload. Okay, so I think this is pretty much, I've gone through all my customers. We got 10 minutes. But I think the key thing I want to tell you is that don't think column store index is only for data warehouse. Don't think I need to match my exact scenario for the design center. We are actually exploring and finding the column store is applicable in many scenarios. In fact, there was one customer I was working with, you won't believe how many rows they got. They had 250 billion rows, 250 billion rows, okay? And they wanted query performance under 3 seconds. There is no way in hell we could do 250 billion rows in under 3 seconds, right? I mean, how could we do it? We created some innovative solutions. We partitioned the data. We duplicated the data in such a way that the queries will be limited to one partition, right? And that's how we were able to do it. Again, their table was only three column table. You don't think of column store for such things. There was no fact table, right? So what I'm saying is, yeah, just think through this one. I think column store is your friend. It can help you in a very significant way. Okay. Any questions for me? So we are still working with many more customers. And let me tell you one thing about myself. I've been with SQL Server for 15 years almost. I moved to SQL Tiger team last year. And my only responsibility is to make our customers successful in our technologies. So all the customers that you are looking at is the ones that I worked with personally to make them successful. And our gain is different. Our gain is we learn from those customers to see what is missing in our products. We get these kind of quotes to help other customers to feel excited about it. And we are obviously in the business to make our customers successful. So if you, for a reason, are thinking about column store and you have questions, Sunil, is this technology available in this kind of a scenario? Feel free to reach out to me. Because for me, it starts from that call. And we will evaluate the workload and give you our recommendations. Of course, the work will be done by you, but we will be your back just to support you. All right? So I think this is all for me, and thanks for joining, and have a great trip home. All right? Thank you.